Knowledge graphs are trending recently in AI space. Many were thinking, will it be as good as vector store? What if I say you can do everything from vector store and much more things too? Let me explain. To ingest a document in vector store, it will be split into isolated entities called chunks. A chunk is then embedded to perform semantic search. We can also add some metadata for further filtering. Every chunk in the database will have this information. So this is a vector store. Along these, if we add few more relations, for example, the order of chunks or linking the references used, we can consider it as a knowledge graph. Since we are only adding information without modifying existing vector store, as we said, we can do everything from vector store and some complex operations too. For example, let's say our RAG business logic is we want to collect chunks which are similar to given query, and we need to collect all the references the chunk points and expand node context to adjacent nodes while checking if they are within the same page. Each part of our query can be translated to its corresponding cipher query, and we can execute all our retrieval logic in a single go. Let's walk through what the cipher query does. First, it will do a semantic search and finds, let's say, chunk 4 matches semantically with our query. Then the references are fetched, which is chunk 1. As for the nodes we traversed, it collects the adjacent nodes, which is chunk 2 and chunk 5. Since we want adjacent nodes to be in the same page, we are eliminating chunk 5 and finally left with chunk 1, 2 and 4. The structure of knowledge graph is as follows. It contains unique entities called nodes, and nodes can have a type attached to it for classification. They can also have metadata with them which are specific to the nodes. Nodes can be connected to each other via relationship. Relationships will have a name and any metadata specific to the relation between the two nodes. This is a basic knowledge graph. To create this one, we can write a cipher that starts with create followed by the pattern. The cool thing is, the pattern is just an ASCII art of our graph structure. Once we execute, our graph will be created. If we want to add more nodes and relationships, we can write and execute similar create queries. Neo4j will do the pattern matching and create nodes and relationships in the appropriate places. Let's see how to automate the creation of knowledge graphs for massive data. If your data is structured like any APIs or database tables, you can write an automation script that frames the cipher query using your DB schema. If your data is unstructured like PDF documents, you can pass them to an LLM and ask to write cipher queries. That's it on the creation. When it comes to selection or deletion, they too are straightforward. You can just replace the create with the match to select the pattern and use return to format it like a table. If you want to delete things, just replace the return with an delete. So now you know how to operate with knowledge graphs. Let's see how your AI agent can use these. To enable your agent to use knowledge graphs, you just need to connect two tools. One is to get the graph schema, another one is to execute cipher queries. To know about the graph structure, the agent can inspect the current schema, which contains the node types, the number of nodes on each type, list of properties and its data type for each node type, the relationships and their properties and data types. It also has information on which types of nodes are connected to which node types. By using these, for the user question, the agent can write a cipher query and use the execute query tool to execute it and get the results as a table. The agent can analyze the results and rewrite the cipher query until it finds the answer. To decide which storage and technique to use, it depends on your data. If your data is unstructured and has no relationships between the entities, you can go with the vector store. If your data can be structured to tables, you can go with SQL database. If your data is semi-structured and has a lot of interconnections between the entities, you can go with knowledge graph.